Okay, in this video, we'll be talking about spanning trees. So, I have already recorded a video on spanning trees. I'll give a link here. Okay, so you could first watch that video and then come to this video so that you'll have a better clarity. But for now, to understand the video, I'm giving 3 pointers for a spanning tree where you will so that you'll understand. One is no loops. A spanning tree should not have any loops, and all the weights, sorry, all the nodes should be connected. Okay, and it should be minimum. If you're thinking about minimum weight spanning tree, the weight should be minimum weight. Okay, and to compute this minimum weight spanning tree, there are two algorithms proposed. One is Prim's algorithm, okay, and the others is Kruskal's algorithm. Okay, we'll in this video we'll actually study both of these. Okay, so let us go forward and understand how Kruskal's algorithm works. Okay, so we'll first talk about Kruskal's algorithm. Right. First step in Kruskal's algorithm is you write down the weights of the edges. We are talking about this example here, which is one of the previous year question. There are many questions in Prim's and Kruskal's algorithms, and very important in graphs. And we expect at least 1 to 2 questions in this area. So very important. Please listen to this video very carefully. Okay. So first step is we will sort out the weights in ascending order. Like you could see, they have sorted it in the ascending order. Okay, so the first step, and the second step is you make a skeleton of whatever we have, A to A, C. Just write down the vertex there, C to E, G, and F. You just write down what are the vertex that are available. Okay, and this next step is you just include whatever the least weight we have. First we have C to D, so we will include C to D. That is, we have 1 here, and we will also include E to G. Say I'm just including whatever the weights that are minimum. We have C to D, which is weight, which is, we are connecting these two, and we are writing the weight because these are the least weight. E to Z also we have connected it like this, and after that we will connect F to G. F to G, the weight is 1. Okay, and B to C we will connect. B to C will connect, and the weight is 2. And D to E, is it? Yeah, D to E will connect, and the weight is 2. Okay, and E to F, can we connect this? If I connect this, this will be a cycle. You could see here, if I connect this, this will be a cycle. Okay, so we are not going to connect it. Okay, next we have after E to F, we have C to F. Can we connect this? If we connect C to F also, there is a cycle, because you could see this is the whole cycle. We'll have a cycle here. So we are not connecting it. Okay. Think C to D we have connected, and we are ignoring C to F. Remember, there should not be any loops. That's one thing that you have to be very careful. When you're connecting, you make sure that there is no loop. Okay, that is the only thing you have to consider here. A to B, yeah, A to B we can connect because there is no loop. So A to B, you have 3. Okay, so B to D can we connect? If you connect, you will get a cycle. C to E can you connect? If you connect, you will get a cycle. D to Z, D to G, yeah, you'll if you connect this will add a cycle. Okay, so we are not connecting it. And A to C, yeah, even if you add it, you will have a cycle here. Okay, so we are not connecting. So what is the final weight here? 3 plus 2, 5, 6, 8, 9, and 10. The weight is 10. This is the minimum weight spanning tree of using Kruskal's algorithm. Okay. So very simple. You just sort out the weights and you just connect such that there are no cycles. If in the exam, if they don't mention specifically about Prim's algorithm, you prefer to use Kruskal's algorithm because it is very straightforward and very easy to understand as well as to implement also. Okay, so now we'll study about the Prim's algorithm. Okay. I hope you understood this. I hope we will continue with Prims. If you didn't understand this, please rewind this video and listen it again. Okay. So the minimum weight we got is 10. Okay. So we'll also do with the Prims algorithm. So let us see how much weight we get. Okay. Okay. We'll talk about Prims algorithm now. Okay. Let us see down here. What is Prim's algorithm? Okay. Starting with vertex A. So I'm including vertex A here. Okay. So the next vertex what should I add? So see here, you maintain this table here, whatever we have given the table, you maintain this table in the exam. So current MST vertices, minimum spanning tree vertices, we have A already included because we start with vertex A. From A to B, we have an edge which is of weight 3. From A to C, okay. From A to C, we have edges 6. Out of which is least? You could see that from A to B, we have 3 and A to C is 6. So definitely the least edge is A to B. So we are connecting A to B. Okay. So what is the weight? We have 3. Okay. And now we have A as well as B in the current vertices. Okay. So we could see we have A and B. So now from A to C, we only have the edge with 6. Now the new weights that are included are B to C and B to D. You could see here from B to C there is an edge and B to D there is an edge. Okay. And A to C we only have at the edge. Okay. These are the 3. See, whatever the vertices that are included, you just write down the edges that are corresponding to it. Okay. With A, I have A to B and A to C. I have written it and I have taken the least among it, which is A to B. Okay. Now, since A and B are included, now A as well as B are included. You could see the graph here. Okay. So now, since both of them are included, now I'll write the vertices along edges along A as well as along B. A to B I have to write, but anyway, A to B is already there. So we have written A to C. We have written, okay, we have written A to B, A to C, and from B to C we have an edge, B to D we have an edge. So I've included both of them. Okay, right. So now, which is the least among these 3? Among these 3, definitely B to C is least. So I'm including B to C. Okay, what is the weight? The weight is 2. Okay. Now, what are the vertices that are included now in the tree? A, B, and C. So this right here, A, B, and C. Okay. What are the edges that we have? You could see from B to D we have an edge, and from C to D we have an edge. So, right, from C, what are the edges we have? C to D, C to E, C to F. Okay, that's it. So, which is the least among it? Which is C to D. Okay. Now, what are the edges that are included? A, B, C, D. Okay. Now, anyway, we have from from C, whatever we have already there here. These will be included again. Okay. And the new edges are from D to E, D to G, and D to C is anyway included. So these two will be added. Could see here. Very, very straightforward actually. D to G we have added, D to E we have added, and C to E and C to F are previous only. Okay. So right. So now among this, which is the least weight? Among these, the least weight is DE. Okay. So we will include DE. See, you just need to include the vertex with least weight. And whenever the vertices are added, you just include the edges like this in the table. Okay. So that's it. Now see. Now what are the edges we have? What are the edges we'll newly add? Newly add wedges are vertexes that are edges that are corresponding to E. We have E to G and E to F. These are the new nodes that will be added because whenever the new node is added, there will be corresponding edges will be added. See here. The new node added is E, will have the corresponding edges with E. Okay, right? Now, out of which least is E to G, right? Right. And G is newly added. So, the vertices corresponding to G will be also added to the above vertices. What are the vertices that should be added? You could see they have G to F, we have G to E, but G to E is already included. So G to E we have 1, okay, we have already included. And G to D, if you include G to D, if you see here, if you include G to D, there will be a cycle. So that's the reason we will not include this. They are ignoring whatever the vertices that are having the same, if we have any cycles, they are ignoring it. So that's why they didn't write. Okay, right. From out of these three, okay, what is the least weight? So this is G to F, which is nothing but 1. Okay, what I'll do is I'll explain it again. Just try to understand. Okay, see here. First, we have included A. Okay, and from A, what are the edges we have? From A, what are the edges we have? We have A to B as well as A to C. That is what we have written here. Okay, so what is the least weight among these? A to B. So we have included A to B. Simple. Okay, so this is 3. Okay, now A, B, both are in the tree. Now vertices that are adjacent to A and vertices that are adjacent to B has to be included. Okay, so vertices that are adjacent to A are A to B and B to C. And from B, we have B to D and B to C, isn't it? Okay, A to B is already included, so we are not ignoring that. So now see, we have included A to C and B to C and B to D. Out of these three, which is the least weight? You could see that B to C is the least weight. So we have included B to C. I hope you are understanding. Okay, right. Now A, B, C, all three are included. So since all three are included, we will write all the edges that are corresponding to A, B as well as C. So we have from A to B, we have 3, but anyway it is included. So we are not writing it again. We have A to C. Okay. We have from A, these are the two vertices. From B, we have B to D as well as B to C, but we are not including B to C because already B to C is done. Okay. So what is the new vertex that is added? That is C. From C, we have C to B. Okay, we are not adding it. From C, we have C to D, C to E, C to F. That's what we have written here. C to D, C to E, C to F. And B to D. Okay, right? A to C we have not included here. The reason is if you include A to C here, definitely will be a cycle. So they have not included it. Okay, you can write it, no issue. But even if you write it also, you will not include. Okay, we already studied Kruskal's algorithm where any loops will be ignored. Okay, that's the reason they have didn't treat. Okay, right. Now see which is the least weight. We have C to D. Okay, so C to D is 1. Now from A, B, C, D, what are the least weight? So you need not recompute A to A, B, and C. You can just compute with D because anyway they will be included in the previous table, right? So we are only interested in finding what are the vertices that are adjacent to D. Okay, so D to G we have, okay, and D to E we have. Okay, D to C we are not include because anyway we have added the edge already, so we are not including it. Okay, so these are the two edges that are added. Previously we have C to E and C to F, out of which least is C to F or D to E, whatever you want to take you can take. So last time we have taken, I think we have taken D to E. This time we will take C to F. Okay, this time we will take C to F. What is the weight? C to F, there is 2. Okay. So this time we have included this. Okay. So if you have included that, then the table changes, I think. Yeah. Now from F, what are the edges we have? We have from F to G, F to E, okay, F to E, and what else? Yeah, F to C. F to C is anyway included, so we are not re-including it. You could see that even if you add these remaining vertices also, okay, we have included now F, okay. Even if you see that, now F to G is the least weight, so there is no cycle also. So I'll write down F to G, okay. Now G is included. Now G is included, isn't it? Yeah, yeah. Now G is included. We'll calculate from G also, is there any vertices that are least, okay. G to E, we have 1. Will it form a cycle? Yeah, no cycle. Okay. G to E, there is an edge, and G to F, there is an edge. G to F, we have already included, so we are not re-including it. Okay. Okay. G to E, we can include because there will be in any cycle. G to E, we could see here. G to F, yeah, G to E. Is there any cycle? No, there are no cycle. Okay. So this is how you can conclude. Now all the vertices are connected. All the vertices are connected. Okay. And now calculate the weight 3, 2, 5, 6, 8, 9, and 10. Okay. This is the minimum weight spanning tree that we have got. Here also the weight is 10. Okay. When you are trying kruskals also, the minimum weight is 10. Now, one thing you have to remember is uh, if you have weights that are repeated, you could see here 1 is repeated twice, I think 2 is repeated 3 times. If you have weights that are repeated, there cannot be a unique spanning tree. Okay, remember this. If the weights are repeated, there can be different kind of trees that will come. Because here you could see either C to F can be included or D to E can be included. Based on that, we have got 2 trees here. Okay, and one more thing is the least weight. There is an edge with one weight 1. Okay, it is not mandatory that it will be included. Okay, any weight that is not included, which is 1. No, as of now in this example there is no such weight, but sometimes there will be a weight 1 edge which may not be included because it can form a cycle. Okay, we'll study about that in a different example, but in this example all the ones are included. Okay, C2s are all included, B to C, D to E. See here, even though we have a weight with D to E which is just 2, okay, but that was not included. Okay, but even though the weight of A to B is more than 2, okay, still it is included. So it is not mandatory that the least weight will always be included. Okay, these are one of the previous gate questions that were frequently asked. Okay, even though there is a least weight, it is not mandatory that it will be included in the spanning tree if the weights are repeated. Okay, so I hope you understood this. So either you do it by kruskals or by prims, either you get different trees if you have the weights are repeated, and you'll get the same minimum weight by doing with both of the procedures. Okay, so what I'll do is I'll give you another question. You just see these kind of questions, the prims or kruskals are looking easy, but actually you have to do it on your own. Then only you will understand exactly have you understood or not. Because while listening, everything looks cool because you know on paper you have not done it. So I recommend you to actually try this question by using Prim's algorithm as well as Kruskal's algorithm, and write in the comments what is the weight that you've got. The first thing is what is the weight that you've got, minimum weight, and the second thing is the weight repeated. Yeah, weights are repeated. So is you just tell me, is there unique spanning tree or any different spanning trees? That is how many planning trees have you got? Okay. So my two questions that I want you to update in the comments is, what is the minimum weight that you got? How many trees you got? Is it one tree or two trees? I want it in the comment box. If you mention it in the comment box, then I will understand that you have understood this Prim's and Kruskals algorithm. I repeatedly say that whenever you see a video or watch a class, it looks easy. But on paper, when you keep, it looks a little tricky. Okay, because you have to observe the cycles also. Okay, so just comment it out, and so that I will understand that you have understood. Okay, okay. Thank you so much. We'll meet you in the next video.